In the previous video, we have created the porosity model, right? So we now have a porosity model that's kind of a that actually populates the entire three-dimensional grid, right? So this is basically a display of the cross section of the porosity model throughout across a hand-drawn polygon, right? Polygon generated cross section. In the previous video, I had a little bit trouble sort of projecting this particular cross section, projecting the porosity onto this particular cross section. The reason was that I forgot to actually check off the porosity, three-dimensional porosity model. So if you put the three-dimensional porosity model on it, it's not going to display the. It's not going to display the. It's going to hide the projection of the porosity on that particular cross section, right? And I was actually clicking on the zone filter thing. If you uncheck the zone filters, then it's gonna clear out every zone, right? So it's not gonna display anything. The correct way is to actually make sure that the zone filter is checked for every zone, or at least the zones that you are interested in. And then you uncheck this porosity model, and then you'll be able to actually see. You uncheck the volume display of the porosity model, right? And then you will be able to actually see the projection of the porosity model across the surface, across the intersection, right? And that's how we can actually create and display the different kinds of petrophysical models, right? So now let's keep working on our project. Once we have a petrophysical model, especially the porosity model, the next step is usually the volume calculation. We want to compute the volume, right? And at this particular stage, we have two buttons. One is called contacts, and the other one is called volume. And this volume button allows us to actually compute the volumes. And this contacts button allows us to actually insert contact surfaces into the three-dimensional model. So let's click on contacts. Right. And it's going to give us this particular dialog box. And let's take a look at what's actually inside of this dialog box. Make contacts. It's called make contacts. Again, we have two choices: either create a new or edit existing. And then if we are creating a new contact set, we can sort of give it a name. Let's just call it contact set. Contact set 1, right? Let's just call it contact set 1. It's not a good name, but it serves the purpose. And then on this side of the box, we can choose contacts, right? By default, we have a gas oil contact and an oil water contact. These two contacts are kind of created for us already. But if we want to create more contacts, we can just use this button. It's going to allow us to insert more contacts, right? And then we can change the name, for example, oil up to, for example, suppose, right? And then change the name oil top or something. Change it to oil top, right? No, top. Oil top. If we want to delete a particular contact, we can just use this button to delete it. So, and then we can also sort of use these two buttons to actually move a particular contact up and down, that kind of thing. Store and populate the contact information, right? Store to save the current contact values as points in the input tree. So it's possible to actually store the contact information. And then if we have a stored contact information, we can use this blue arrow to point it in from this input pane into this particular box, so that we can sort of populate our model. And then we have these three checkboxes, right? By default, it's the same for all zones. But if we uncheck this box, it's going to allow us to actually specify the contacts or the depth of contact. It's the z value of contact. It's a z value. It's the z value of contact for each of the different zone. And we have like a 1, 2, 3, 4, 5, 6 zones. And then if we uncheck the same for all segments, then it's going to allow us to actually specify the z value of contact for different zones in different segments. So the segments are basically just a lateral division of the model into like a multiple parts, right? And this kind of zone is basically just a division or some kind of a partition of the model into like horizontal layers, that kind of thing, right? So by uncheck same for all zones and same for all segments, we can sort of specify the contact depth or contact z value for different lateral portion or lateral partition and a different vertical partitioning, right? So we have lots of different choices. Right? And then by default, the use regions property is unchecked, but if we check it, and then we can sort of specify different contact region, that kind of thing, right? So basically, those boxes allows us to specify the contact z value at a different level of details, right? For example, suppose use regions property. Let's not use zones. Let's use some kind of fluvial phases model. Right? Then it's going to allow us to specify the contact for the contact z value for different phases, right? But let's uncheck it for now. Right? And then for every segment, maybe let's still put it back, right? Put it back. So we have this checkbox here, right? And this checkbox is called use surface. If we check it, if we put a check mark on it, then it's gonna give us this blue arrow. And this blue arrow is gonna allow us to select a particular or prepared surface data from the input pane, and then we can point it into this particular box. And then the segment, the contact z value are gonna sort of follow that particular surface that we used that we prepared earlier, right? And that surface could have sort of variations in space, right? Which allows you to actually sort of specify a spatially varying contact z value. And this checkbox exists for all the zones, for all the layers and all the segments, right? So you can sort of see every box has a checkbox in front of it, which allows you to specify a particular prepared surface, pre-prepared surface. But let's still put it back as for this exercise, we're going to use a very simple case, right? We're going to do the simplest case. So for gas-oil contact, we are just going to specify a negative value, right? That's GOC gas-oil contact. Let's give it like a minus 1850. Minus 1850 meters, basically. It's a constant value. It's a constant Z value. And then for oil-water contact, let's give it minus 1950. Oh, sorry. Minus 1950. Right. That's OWZ. Right. And that's pretty much everything for this particular box. Make regions property, right? This says make regions property. So for different, for example, for different fluid phases, we can sort of do this, right? And then, but let's not do that. Let's not do that. Now let's just click on OK. And then it's going to compute the surfaces. And as soon as the calculation is completed, we're going to see this particular item that's called fluid contacts. This is inside of the our 3D model, 3D demo world. Right. And if we expand it, we will be able to actually see this contact set 1. This is the name that we used when creating that particular contact set. Right? If we expand it again, we're going to be able to see the two contacts, gas-oil contact and oil-water contact. We try to display them, right? So the gas-oil contact is the gas-oil contact is going to be at minus 1850 meters, and then the oil-water contact is going to be at minus 1950 meters. Right? But this display is kind of distracting, right? We can adjust the display by double click on the fluid contacts. So here we can actually make changes to how the surfaces are going to be displayed. But for now, it's we are seeing is basically the three-dimensional porosity volume, right? But maybe that's not a good background. Let's look at the horizons. So let's turn off the properties, and then let's go back to the horizons, base Cretaceous, top Tarbert 1, Tarbert 2. So let's just put all the horizons on it, and then you will be able to see what Petrel is actually coloring, how Petrel is actually coloring the different regions, right? So by default, these two checkboxes are checked, right? So fill horizons. If you uncheck it and then click on apply, then the horizons are gonna appear like these kind of a contour surfaces, right? But let's still put the fill horizons on it. And then the checkbox shows show contact surfaces, right? Suppose we uncheck it. Now we can actually see the spatial or lateral distribution of the different of the oil and gas and water, right? So gas is like in the red region, and the oil is in the green region, and the water is in the blue region. We can change the color, right? We can change the color depending upon how the convention in your company or in your working group. You could change the color to follow that convention, and then you can also change the material. By default, it's plastic. If you apply bright plastic, that did not seem to actually make any changes. Metal, maybe. Right, so gives you some slight changes. Maybe the reflection is stronger or something. But wood. Let's see what's actually the effect of wood. Less reflection, maybe. But all these changes actually don't really make too much of a difference, right? And then if you wanna sort of have some kind of transparency, right? But again, the transparency does not seem to actually have a good effect. So let's put it. Let's change it back. And then again, you can sort of change the style of the lines, right? Maybe change its color from white to some other color, let's say black. Then all the contact lines are gonna be displayed in the black lines. And then you can change the width, maybe make it thicker. So we can see the contact lines more clearly. So this kind of style change are kind of are inside of this settings dialog box for fluid contacts. You have to sort of double click on this fluid contacts folder in order to actually bring out that dialog box. So that's sort of the display of those contact lines, right? Display of the contact lines. Fluid contacts, right? Is there anything else inside of this box? Probably not, right? So once we have a fluid contact, once we have created all the contact surfaces, either by just specifying the values, z values, or by sort of using prepared surfaces, or by some other sort of methods. Once we have created this particular contact surfaces, we can click on volume and then try to carry out the volume calculation. Again, we see something. It's going to create a new data, right? It's going to create a new data, and the data that's going to be created is called cases. Right? It's every calculation, every volume calculation is going to be labeled with is going to be called as a specific case. For now, there's no cases existing, right? All the cases are underneath the cases tab. If you click on it, there's nothing in it. Right? For now, it's empty. There's no cases that's being computed. Let's call it cases 1. Let's give it a name, a case 1. Case 1. And then we will need to actually specify the grid. What's going to be the grid we're going to use? Right. For now, we have only one grid. So that's 3D demo grid, right? But if we have multiple grids, we need to actually select the correct grid for computing for the volume calculation. And then we have properties, settings, hints, this kind of thing, right? The hints basically display some useful equations, right? If you kind of forgot about what's actually the meaning of those specific names, you can sort of come to this particular hints section, and then you have constants, BO, oil formation volume factors, this kind of thing. These volume factors are, how do I say? So when the oil and gas is kind of buried underneath the ground, they are under pressure, right? They are under pressure and a high temperature. So their volume is going to be different from after you bring those oil and gas to the surface of the earth, right? So, and this kind of BO and BG, this kind of volume factors accounts for the volume changes, the volume ratios when the hydrocarbon is buried, and then when the hydrocarbon is brought to the surface of the earth. Of course, you can sort of look at those question marks and try to understand what's actually happening, right? And sometimes you might need to actually resort to a textbook or something, or just by Googling, right? You can Google those specific names and specific volumes, right? For example, STOIIP, right? It's kind of a long name. It's kind of difficult to remember for persons who are not kind of used to this kind of terminology. It's called stock tank oil initially in place, right? It's got quite a complicated formula for computing it, right? HC usually means hydrocarbon. PV usually means pore volume, that kind of thing. HC PV, that means hydrocarbon pore volume. O means oil, right? So and GIIP gas initially in place. That's a number for gas, basically. Yeah. So in the hint section, it's gonna try to explain some of the notations, right? But let's go back to the properties section. Let's go back to the properties section. So in the properties section, it's gonna allow us to specify the contact surfaces that we have created in the previous step, right? So in the previous step, we created a gas-oil contact and then oil-water contact. We have created these two contacts, right? By default, it's just going to be oil contact, right? So this oil is checked, but not the gas. So if we want to add a gas contact, we have to check this. If we want to add an oil-gas contact, we have to check this one, right? And then once we check this one, this gas-oil contact is kind of something that we have to sort of specify, right? And then we have these three checkboxes. By default, this part is grayed out, right? This checkbox means no contact. no contact. So if the box is checked, it means that there's no contact. But if the box is unchecked, then we have to specify some kind of surface for the input, right? So if you check it, then you don't have to specify the input. Don't have to specify this particular interface, which is oil-water interface, right? Water-oil contact. Right? But if you uncheck it, you must specify a oil-water contact now, right? And this gas-oil contact is kind of mandatory because you cannot uncheck this box, right? Once you have added this particular gas, if you have added this gas phase, then this interface becomes mandatory, right? But if you don't add this gas phase, this gas, then this box is checkable. You can sort of click it without specifying the gas oil contact, right? So, but let's put the gas back on, and now we have to specify two interfaces. One is gas oil contact, right? Let's just point it in there, and then the other one is the oil water contact. And then let's just select it and then point it in there. Right? And that's pretty much the specification that we need to actually specify for the fluid zones for this particular tab. Right. And then we have to move on to the next tab. That's the general. Right. And in this general section, we can select the porosity and then net to gross ratio. We have two boxes. Depending upon the petrophysical model that we have created, this box may be checkable or may not be checkable. So if you uncheck it, then Petrel is going to allow you to select a particular petrophysical model. Let's say porosity model 1. Porosity model 1 was the porosity model that we created in the previous video. Right, if you still remember, right? This porosity model 1. Right. And but we did not actually create a net gross ratio volume. Right? If you look into the properties folder, there's no volume. There's no volume that's called. There's no petrophysical volume or property volume that's called net gross ratio. Right? We have this NTG channel Z, but that's not the same thing as net gross ratio, right? If we want to sort of do a net gross ratio volume, it's possible, right? Because we have well logs. On the well logs, we have net gross ratio, global well logs, right? Net gross, we have this log. So in principle, we could just upscale this net gross ratio log and then sample them into the cells that's penetrated by the wells, and then we can just build a volume net gross ratio model by using some statistical or Kriging algorithm. Right? We can create, in principle, we can create a volume just like a porosity model, this kind of porosity volume, right? But we didn't do that. Right? And Petrel actually knows that we don't have a volume for net gross ratio. Right, so by default this is checked, and you cannot actually uncheck it. Right, there's no way for you to actually uncheck it. It's grayed out because we don't have a net gross volume. If that's the case, what you can do is to actually specify a constant value, and this constant value is going to be applied to every cell in our model. Right, and let's give it some value. Let's give it like 0.8 or something. Right, some arbitrary value for exercise. Right. Practice purpose. In practice, you may want to actually create a net gross volume by extrapolating or interpolating the well log, upscaled well log data. And then we can move on to the oil tab. Right, let's look at the oil tab. And inside the oil tab, we need to actually specify the saturations for different hydrocarbon intervals. Right, the saturation. So S means saturation, and then W water, and then O means oil, and G means gas. So it's the saturation for these three different phases. Right. And for this particular exercise, let's just let's just give some fixed values. Say for SW, let's give it as 0.3. And then for SG, let's just keep it as 0, right? And then these are the this BO, that's the volume factor. That's the volume factor that accounts for the kind of changing volume at the depth and at the surface, right? And then let's give it like 1.21, right? 1.21. And that's so ratio of solution gas oil at the surface. So we don't really need to change this particular factor. And the recovery factor, let's give it just a 1, right? So again, if you have confusions about the meaning of those different names, right, you can either Google or look into the documentation, right? And that's pretty much everything we want to change for the oil tab, right? And then we can move on to the gas tab. Again, saturations, right? What are the saturations? So in this part, let's for SW, let's give it still 0.3, right? And then SO, let's give it like 0.4. So the saturation for gas is going to be 1 subtract 0.4 subtract 0.3. That's 0.3, right? That's exactly 0.3. And then BG. BG is not 1. It's so it's 0.0009 with 3 zeros in front. And that's what we want to specify for the gas part, right? And that's all the tabs underneath the properties tab. So now let's move on to the settings tab. The settings tab pretty much allows us to actually specify what's going to be created once the calculation is done, right? So we've got like 3 different tabs. The output tab, right? Inside the output tab, we can it's got like 3 columns, right? The first column is called make property. So if we select some of the checkboxes, then after the calculation is done, we're going to have more properties underneath the properties folder, right? For now, the properties folder has this many properties that's inside of it, right? So if we select, for example, bulk volume, then afterwards, this is not the bulk volume here. And then suppose we select for example, pour volume, right? So after the calculation is done, we're going to have a pour volume property that's listed underneath the properties, right? So depending upon what are the sort of values or those things that you care about, you can sort of select the appropriate checkbox. So suppose we want to do this VB net volume VN, and then HCPV oil, HCPV gas, right? Hydrocarbon pour volume oil, hydrocarbon pour volume gas. And then let's do STOIIP, the so-called stock tank oil initially in place, and then GIIP, gas initially in place. Right? That's all the properties that we care about, that we want to create, right? And then all those selected properties we will be able to actually estimate the values also inside of our report, right? So later on, it's going to create a spreadsheet report, and all those values, all those properties that we have put a check mark on, will actually appear in that spreadsheet report. And then in the second column, it's called make volume height map. Right? This is again a quite useful visualization for us to actually determine where those properties are kind of high and where those properties are kind of low, that kind of thing. It's going to give us a 2-dimensional or lateral map, which allows us to actually discover or examine those different properties. And if we would like to actually make some volume maps, we have to check the box in front of it. Suppose we want the STO, let's see. Suppose we want the STOIIP in oil, right? We want to create a volume height map for STOIIP in oil. If we click on this checkbox, then by default, STOIIP in oil in the make property column is going to be selected mandatorily, right? So you have to sort of select this one, right? So you will, and then there will be an STOIIP in oil property created inside of the properties folder after the calculation is done, right? But for now, let's not create a volume height map yet. Another way for making a volume height map is to create the property first, and then later on we can double click or right click on the created property, and then select the operations tab in the dialog box, and it's going to allow us to create those more volume height maps also, right? But this is just a convenient way for us to actually create those volume height maps during the calculation. And then on the third column, that's the make spreadsheet report. And then we have just one button that's called report setting. It's called a report setting. So if we would like to actually sort of specify how the report is going to appear, right, we can click on the report setting. So by default, it's going to actually report all the values, all the different kinds of values that's listed here, right? From bulk volume to recoverable gas, those things, right? But you can select a portion of it, right? Suppose you don't want to look at the bulk volume. Suppose you don't want to look at those things. Then it's not going to report these recoverables, right, in the report. And then the value format, by default, it's listed as 6 here, right? This 6 is actually the exponential of the tens. So all the values that's going to be computed are going to be in terms of million. Million is 10 to the 6th power, right? 6th power. But suppose the volume is actually a lot higher than million, right? Suppose it's like a billion or something, 10 to the 8th power or 10 to the 9th power, that kind of thing, right? And then this 6 may not be kind of enough, right? You have to sort of increase 6 to like 8 or 9 or something. Right. And if the reservoir is pretty small, right? If it's like a less than 10 to the 3rd power, then if you put a 6 as the kind of exponential, then you won't be able to see the significant digits. You will just see zeros in the table, right? In the spreadsheet table, right? If that's the case, you have to sort of change the 6 to like a 3, right? So every value is going to appear in terms of the thousands, or in terms of 10 to the 3rd power instead of 10 to the 6th power. So this is a way for you to actually adjust the scale that's going to be used to represent all those different numbers. And then you also have the format. By default, it's going to allow you to specify just the zones and the segments, right? Suppose you have different we have 6 zones, right? From base Cretaceous to like top Eve, we have 6 zones, right? And then our model actually has like 4 segments. So by default, it's going to report all those different values for the 6 zones and 4 segments, right? But if you also want to report everything based upon phases, right? How many phases? We have like 4 or 5 phases, right? We have 5 different phases. So then it's going to report all the values inside of each zone and a segment, and then for each phase, right? And then if we have boundaries, we can check on boundaries, right? And then if we have hydrocarbon intervals, so we do have hydrocarbon intervals, right? That's the 2 contacts, the water. It's going to report all those different values for different hydrocarbon intervals, right? So above the water oil contact, above the gas oil contact, below gas oil contact, below water oil contact, all those hydrocarbon intervals, it's going to report all the different values. And then contact regions. So for our experimentation or for our exercise, let's just select the zones and the segments, right? And then without changing anything else, let's click on OK. That's everything we want to specify for report settings. And in the report settings, we sort of see phases and the boundaries, right? Here we have a tab that's called phases, right? And if we want to use phases, if we want the calculation to be carried out for different phases, right, then we can select the phases model. And then it's going to compute all those values for different phases. But let's not check that box yet. And then boundaries. There are different ways for specifying boundaries, right? For example, if you want to use a polygon, we've got lots of polygons. Oh no, we have one polygon, that's project boundary, right? If we select this box, check this box, then we can actually select this project boundary and then put it in there, right? But the project boundary is like the entire volume already. Unless you have smaller polygons or smaller boundaries inside of the project, then the calculation will not be actually really useful. So let's get rid of it, right? And then wheel boundaries will influence radius. So this is going to allow you to actually compute those properties in regions that's kind of surrounding each of the wheels, right? Or the wheels that you have selected inside of this particular box. And then the radius surrounding the wheels is going to be set at this particular value, 700 meters or something, right? And that's boundaries. And that's pretty much everything we need to actually set. We need to actually compute, to configure. And then let's go back to the cases tab. And now we are ready to actually do the calculation now. We can either click on run. We have to actually click on run, right? If we do not click on run, just click on OK now, then it's going to create a case. Right? But you have a question mark on the case, which means what? Which means this case hasn't been actually carried out, hasn't been computed yet, right? So if you want to sort of actually do the calculation, if you want to actually run it, if you want to, you have to sort of rerun workflow, run volume calculation. You have to select right click and then select run volume calculation, right? So it's kind of important to remember that to click on the run, right, before you actually close the dialog box. Let's click on run. So it's telling you that our 3D demo grid has negative grid cell volumes when cut by contact, right? We know that. We actually know that, right? But it's a kind of a very small percentage. It's just 1 or 2 cells that actually has negative volumes. But it's okay. It's a very small portion of the mesh actually has negative volumes. And this kind of warning message is kind of useful for us to know that, right? And at this point, let's just close this box. And now we have a question. We have a case that doesn't have a question mark on it, right? And then it's creating this output sheet. Right? It looks like a Excel spreadsheet, right? And then it's got different sections. For example, the version of the Petrel that's used for creating this spreadsheet. The project, the date, the username, the name of the model, the name of the grid, units, the hydrocarbon intervals, gas oil contact, and the lower oil contact, this kind of thing. And then general properties, porosity model net growth was set at as a fixed number, right? And then properties in gas interval, and then it's reporting the different kind of saturation values that we specified during the inside of that dialog box, right? And then properties in the oil interval, again, those values, the water saturation, SW, SO, and SG, those values were all specified in our volume calculation dialog box. And then that's the case, right? So bulk volume, 2137 times 10 to the 6th power cubic meter. And then net volume, 1710 times 10 to the 6th power cubic meter. And then pore volume, that's 234 times 10 to the 6 million cubes. So this row basically gives you the total amount, right? And then underneath it, you will be able to see the partitioning among different zones. For example, for base criteria to top bulk volume is 681. And then for Tarbert 2 to top Tarbert, that's 227 for bulk volume, that kind of thing. And then for different segments, and then even more detailed results. even more detailed results. That's for each of the zone and each of the segment. So for base Cretaceous, we have like 4 different segments, and then for Tarbert 2 to top Tarbert, we have like 4 different segments, and then it's reporting all those different values for every configuration. Right? And this is called the volume. This is the result of the volume calculation. And then if you look into the properties folder, you're going to be able to see all those values, right? All those properties that's newly created, right? We selected like 5 different properties in the settings tab in our volume calculation dialog box, right? So here it's 1, 2, 3, 4, 5, 6, 7. Okay, so it's 7. It's 7 properties. Let's just take a look. Right, that's bulk volume, net volume, pore volume, HCPV oil, and HCPV gas, right? And then STOIIP, and then GIIP, right? So these are the properties created by the volume calculation, right? And this spreadsheet, and so the properties have been kind of stored into the properties folder. So these are there, and this spreadsheet, this output spreadsheet can also be stored to disk. If you click on this save button, it's going to allow you to actually store this particular spreadsheet into a text file, right? And later on, if you want to sort of print it out or display it in some other software or onto the projector or something, you can do that by using this particular file. But now let's just cancel it, right? And if you don't want to sort of look at this large spreadsheet, you can just close it, right? But closing that spreadsheet doesn't mean those data has been destroyed. It doesn't mean that. So if you right click on case 1, if you right click on case 1, and then there's an option that's gonna allow you to display that spreadsheet again. It's called make volumetric report, right? It's called a make volumetric report. It's not going to do the calculation again. It's just going to bring out that particular report. This run volume calculation will do the calculation, will redo the calculation, but this make volumetric report is just going to bring out this output sheet, spreadsheet that's already been computed and stored somewhere. So let's still turn this thing off. So when we did the volume calculations, we saw some option that allows us to make volume height maps, right? It's actually quite a useful map. Suppose we would like to actually create a STOIIP volume height map. We can check this box, right? And then smooth result, it's gonna sort of apply some kind of smoothing to the interpolated map, right? And then if we want a finer grid, then we can reduce the X ink or Y ink. It's basically creating a 2-dimensional mesh, and then try to populate all the grid points with the correct STOIIP values. That's obtained either by interpolation or extrapolation or some kind of algorithm, right? And if we want a very dense 2-dimensional mesh, then we can just reduce those 2 increments, right? And if we click on run, it's going to rerun everything, and then it's going to try to sort of create a new set of properties underneath the properties folder. That's not exactly what we wanted, right? In this case, we can just click on overwrite existing properties, right? Let's click on it. And then all those properties are going to be recomputed, but it's just going to replace all those properties that's already underneath the properties folder. And I think that's everything that we need to specify. Okay, so edit existing, right? We're just redoing the case 1 situation. We're going to redo the case 1. Yeah, I think that's pretty much everything. Yeah, and now let's click on run. It's creating that spreadsheet again. Right, but this time it's not really something that we care about. We care about the volume height maps, and the volume height maps are actually stored inside of the input pane. So here you see a new folder that's called volume maps, and then inside of it you're going to be able to see the STOIIP case 1, right? And it's actually a two-dimensional figure, so we have to go to a 2D window in order to visualize it. In this window, what's being visualized the net map for the NTGC and the channels end. Let's uncheck this thing, and then this time let's check this one. Right. Now it's giving us as a STOIIP. If we want to adjust the color range, oh, it's already on max scale. And then color legend, let's put on the color legend. And now it's giving us some kind of visualization of the STOIIP in a map, right? And another way for creating STOIIP maps is to look into the properties folder, right? Look into the properties. In the properties, we also have this STOIIP. That's a property, right? That's a property. And if we double click on it, it's going to give us this settings dialog box, right? And inside it, we're going to have this tab called operations, right? And this particular folder, that's called a make map from property, right? You can choose make average map, make volume height map. So if you actually double click on this one, or if you choose this one and then click on run, it's going to create an STOIIP height map that's just like this one, right? But what we would like to do is actually to do this thing, make volume height maps for each zone. So we have like 6 different zones, and then we can do this volume height maps. We convert the volume height maps for all the zones, right? For all the 6 zones, right? And if we have selected a particular map type, and then the box underneath it is going to tell us what kind of calculation is being carried out, right? So that's sort of the mathematical formula, right? That's the property. That's property at the cell, right? That's the STO. In our case, it's STOIIP, right? So it's STOIIP at the ith cell times the height of the ith cell divided by the volume of the ith cell, right? And then do a summation, and sum it just for the XY position. So for all the XY position, it's going to sum over all the cells along the Z direction. So our look, so the appearance is going to like a map. And then it's possible to specify a surface template. So if you move your cursor over here, it's going to tell you that the result will be given the same geometry as this particular surface, right? So you can prepare a surface in the input pane and then point it in here. Then it's going to use this particular surface as a template, and the result will have the same kind of geometry as that surface, right? We are not going to import any kind of surface template. So in this case, it's going to auto-generate the surface by using that 3D grid. And at this point, we can just click on run. And then we're going to see another folder that's called volume height maps for STOIIP, right? And then we're going to have like 6 different maps for each of the zone. Right. Let's close this dialog box and right. So the file name actually is named according to the zone ID, zone name basically, right? So if we would like to display them, right? So this is the STOIIP for base Cretaceous to top Tarbert. I think the color range is kind of adapted to the values. Is it automatically adjusted? Yeah, the color table is automatically scaled, so it's already automatically scaled. It's not displaying the contour lines, but this can be configured. It doesn't really matter too much. That's for the second zone, Tarbert 2 to top Tarbert. And then this is for Tarbert 1 to Tarbert 2. Right? Then this is for top Nis to Tarbert 1. Right. So let's still look at this one. Let's still look at this one. And sometimes we would like to actually print out this kind of a map, this kind of a figure, two-dimensional plot on a map. And if that's the case, Petrel allows us to create a map window. So here we have a choice that's called a map window. We haven't looked at this particular figure before, window type before, but let's click on it. Right. Now we got a map window here, right? And for now, there's nothing displayed inside of it. But let's click on STOIIP. And then we're going to be able to see the STOIIP in this particular map view. Right. For now, the contour lines seems quite complicated, and the contour lines and the color actually display same kind of information, right? So it's really unnecessary, right? So what we would like to do is actually to use the color to show STOIIP, and then what we would like to do is to actually display to use the contours to actually display structural information, right? Structural information. So structural information is actually inside of the horizon data, right? Do we have a horizon? Yeah, we have a horizon surfaces depth, right? This kind of thing, right? So how do we actually combine both kinds of information, both the structural information and then STOIIP information into like one map, right? And we can do that. It's possible. So first, let's double click on STOIIP to bring up the settings dialog box, right? And then we're going to turn off the contour lines. So by default, the contour lines are going to, so this checkbox in front of show is kind of clicked, right? Let's uncheck it and then click on apply. So now we only see the color, right? There's no contour lines displayed on it. And we'll try to actually display some structural information on top of the colored background that's displaying the STOIIP information. Right. So suppose we have a horizon contours depths, but those are contour lines. Those are not surfaces. But here we have contour horizon surfaces depths. That's actually surface data. Suppose we choose top Nis. Right. But the problem is that the top Nis is displayed both in terms of contour lines. Those are actually elevation. The numbers displayed here is actually Z values, right? It's Z value. So it's got contour lines and also color fields, right? So what we would like to do is actually get rid of the color fields. So again, let's double click on top Nis. And for the styles tab, we have a tab that's called solid, right? And now show is checked. So let's uncheck this one and then click on OK. And now we can sort of see the contour lines that's from the knees horizon, top knees horizon. And then the color that's in terms of STOIIP. Right? And those contours actually gives us some structural information, whether that region is kind of closed or whether this region is sealed, right? For example, those thick lines, those thick contour lines, give us some indication about where the faults might be. Right? If we want to see the faults, do we have a fault? Fault stick depths, that's fault stick data. Do we have fault surfaces? No, we don't have fault surfaces here. Maybe here, right? Faults. So we can see the faults, right? But it's probably not a good display. It's displaying all the faults in all the zones, I guess. So that might require some kind of fault filter. So we can just display the faults in a particular zone, right? So this fault model is not allowed to be displayed. Fault filter. Okay, so fault filter. Let's uncheck this, and then maybe top knees, just the one zone, and then let's put down the faults. Right. So this might be a better display, right? Might be a better display. If it's not top knees, let's look at Tower 1, Tower 2, top Tower, base Cretaceous. So for base Cretaceous, all the faults are appearing as dash lines here. Maybe Nice 1. So it's going to take some time to actually configure this particular plot to a way that's kind of exactly suitable for display. Right. Suppose let's just use base Cretaceous. So and then we can also say fit to width, and this is going to give us a much bigger map. Maybe fit to height. Yeah, this appears to be quite informative and quite interesting figure. Right. So that's how you can actually do the volume calculations. By first we have to sort of insert the contact surface, construct those contact surfaces, and then we can use the volume calculation dialog box to carry out all those calculations. Right. And then we can just extract all those properties that we're interested in. So here it's displaying STOIIP, right? That's for all the zones. But if we are interested in looking at a particular zone, then we can just display it on here. But of course, we have to reconfigure all the different settings, right? Get rid of the contour lines. Right. So that's for base Cretaceous top volume to top Tarbert, right? And this is for top Tarbert 2, right? Yeah, we can pretty much do the same kind of thing and then display those STOIIP values as a color, and then the contour lines is going to give us indications about the structure. And in the next video, we're going to start to, depending upon the availability of the data, we're going to sort of start to either do some kind of data analysis to look into this particular button, right? Or we can start to work on the seismic data, right? Because we haven't actually touched on some seismic data yet. But we do have a three-dimensional seismic volume that will allow us to actually practice upon, right? But maybe a better idea is to just go through the data analysis dialog box before we actually start to do the seismic analysis. Right, depends. But anyway, this is pretty much for everything for this particular video.